Hello, algebra students. We are going to continue with 7.8 multiplying polynomials. We did a lot of binomial, multiplied by binomial, and we're just going to show you a few different things that you might run into. So you might see a binomial multiplied by a trinomial, and the process is the same. So if you're like, hey, I think I want to try this on my own, feel free to go try it first. But I'm going to just go through like 3 quick questions or 3 quick examples here. So if you had notes from our previous day of 7.8, please go grab those, and we're just going to add on to it. If you want to do a new sheet, do a new sheet. That's fine. Sorry, my papers were falling apart there. So I'm just going to call this like day 2. I don't know what to call it. I'm going to separate that out there. Number 5. And number 5 is going to look very, very similar to what we've been doing. X plus 3 multiplied by x minus 3. The same exact process. I want to keep continuously telling you that everything is staying exactly the same. I pretend that 3 is not there. I just look at one of the terms for the binomial, and I'm going to distribute that to both terms. X times x is x squared. X times negative 3 is negative 3x. Same process, nothing has changed. Let's distribute this 3. 3 times x is 3x, positive 3x. 3 times negative 3 is negative 9 or minus 9. Okay, we're done. That's my answer. And you should be saying, oh, but I know there's a catch. There's something going on. What is wrong? Well, not wrong. What needs to happen? And in this case, we would combine like terms. So I have a negative 3x and a positive 3x, and they actually eliminate. That's 0 x's. They're going to eliminate. I mean, you could write 0 x's, but don't, because we don't write the number 0 like in an expression or something. We wouldn't write plus 0. So in that case, they cancel out. Everything else stays the same. So you might take 2 binomials and multiply them out, and if things cross out or things are not working out that way, you might get a binomial from multiplying 2 binomials. That will sometimes happen. So that's one example. That might be new, like it's not like new information, but new outcome or a new example. All right, number 6. Ooh, this is a good example because it looks like this. I'll give you a second to kind of catch up and write that down. X plus 2 squared. Well, what does squaring mean? Like if I have x squared, it's x times x. If I have 4 squared, it's 4 times 4. So if I have x plus 2 squared, it is x plus 2 times x plus 2. And you do it exactly the same. So sometimes you might see a binomial and you're like, wait a minute, I thought we were supposed to be multiplying polynomials. This is a binomial multiplied by a binomial. It just happens to look like that in disguise. Same thing, take the first term, multiply it by all the consecutive terms in the second polynomial. X times x is, I should have used that color, sorry. X squared, x times 2 is 2x. And then the same thing over here. You're going to distribute the 2 to the x and distribute the 2 to the 2, which is 4. That's technically your answer. Now obviously there's some combining that needs to happen, so you're going to end up with 4x plus 4. So keep that in mind, that if you're looking at something going, oh, wait a minute, that is a binomial, but there's nothing it's being multiplied by, remember that it could be multiplied by itself. So number 7. Number 7 might look a little bit crazier, but it's the same process. I'm going to say that a million times, but I'm going to keep saying it. It's the exact same process. We're going to do a trinomial multiplied by a binomial. So my trinomial is 2x squared plus 2x plus 1. And then my binomial is 2x plus 3. The process stays the same. In fact, I'll even do this so you're just focused on this example. There's no, keep saying there's no mistakes, but there we go. Okay, there's nothing that's distracting you. There are 3 terms. 1, 2, 3. This is kind of hard to see. And we're going to distribute the 2x squared twice. We're going to distribute the 2x once, and then we still need to distribute a third term. So the only thing that changes is this one. We're still going to distribute everything else. I'm going to distribute this to both terms like that. So I have 2x squared. I think I'll have enough room. I might write it down here actually. 2x squared multiplied by 2x. Well, 2 times 2 is 4. X squared times x. Oh, I already wrote the x. So 2 times 2 is 4. X squared times x is x cubed. Because x squared is x, times x, which is x cubed. 2x squared multiplied by 3. Well, 2 times 3 is 6. 6x squared. Okay, same process. Nothing has changed so far. We're going to do this as well. 2x multiplied by 2x. That's 4x squared. 2 times 2 is 4. X times x is x squared. 2 times x is 3. So that's 6x. This is the only new part. So in fact, not even like new content, just one extra step. We still need to distribute the other term. So in that case, 1 times 2x is 2x. 1 times 3 is 3. At that point, you now have your answer. Now, is it simplified? Is it ready? No. But you've taken and distributed all of the terms to the second piece. So is there any other x cubes? Nope, that is the only one. Are there any x squareds? Yep, those combine and I'd get 10x squared. Are there duplicate x's? Yep, 6x and 2x are 8x. And then there's no extra constant. So 3 is always by itself there, or is also by itself there, not always. So in this case, remember for these different types of problems, these are problems that they're not changing anything that you know. It's just that the outcome might look different, or the original problem might look a little bit different.